Good day, everybody, and you're most welcome to today's session of the CNPS. Whether you're logged in through Facebook or YouTube, or we have a few people in our green room, so we're hoping to engage with you all presently. Now, this is one of the fortnightly technical sessions. My name is Ian Cowan. I've been asked to moderate these sessions, these technical sessions, which we hold every 2 weeks. Now, the other weeks, we hold a more traditional meeting where the president of the CNPS, David de Hilster, addresses some fundamental questions in physics. Now, last week, we actually had a lifetime presentation to Glenn Borchardt. So we have various things going on. So subject to force majeure, we would hope to have a meeting every week, and every 2 weeks we have these technical sessions. Now, we have an interesting talk scheduled for today, but unfortunately the speaker hasn't turned up yet. So I'm hoping in the next few minutes he will appear. I'll announce him though. He's Professor Amrit Srečko, I hope I'm pronouncing the names correctly, from the Bijective Physics Institute Stationary Cosmology Initiative in Ljubljana in Slovenia. I understand he actually was the founder of the Bijective Physics Institute, and he'll no doubt be telling us exactly what this is all about. Now, I had a quick research on this, and my understanding of a bijective set or bijective sets would be maybe you'd have two sets where each element within the set is uniquely mapped to an element in the other set. That's what bijective means. And I think, jacta would be the Latin for throw or cast. It probably comes from like adjective or bijective. When Caesar was crossing the Rubicon, he said, alea jacta est, the die is cast. So I think it's the same root. But obviously, Professor Šorli will give us more information on that. I actually believe also, I'm guessing a little now, but I think the bijective nature of his analysis is that he's, mapping a one-to-one correspondence between models and reality, which I think he would probably claim is not really done. These models are sort of airy-fairy things which are not strictly mapped to reality. And he will be dealing with some cosmological areas as well, which come with it within his study. So that's that. Now, I'll just see, has he appeared? I don't think he's appeared yet. It's actually, it's 3 p.m. Greenwich Mean Time now. It's 10 a.m. Eastern Standard Time, North American. It's 4 p.m. Ljubljana time. So I think he shouldn't have made a mistake on that. In fact, he was telling us what time it was. But we do have a bit of a fallback, although I'd be disappointed if he doesn't appear. We have Nick Percival, Jim Keane, Bob Gray, Dennis Allen, and Franklin Hu in the green room. And I can bring you up to have a discussion. Now, in particular, Nick actually was instrumental in organizing this in the first place. He had contacts with Professor Šorli, and he's offered maybe to show a video, and maybe we can discuss that. And in fact, James Keane, who's given us 2 talks already before the speakers were due to give talks on their subjects, has offered to give us a talk on his work as well. He has some ideas about gravitational constants and so on. So let me just see private chat. Does he have an email? Can someone email him? That's what Bob Gray said. Bob, I've sent him an email saying I'm here 10 minutes ago. Please come in. And he said he would appear 10 minutes early. So I'm going to bring the people in the green room up because we don't want to leave everybody just hanging there. Unfortunately, Bob, we don't have a telephone number for Amrit. Otherwise, we would. And Harry is here as well. So I've got you all up now. And I hope we don't degenerate into a discussion again just among ourselves on whether I made a good
It's
attempt or a
working
bad
for me.
attempt.
Maybe it's not working for him. Maybe he's got a problem.
It's possible because I actually put him off arranging
Hey,
a
you're
test.
in the problem with this StreamYard.
Yes, quite so. But Harry, he requested actually that we do a test maybe a few days beforehand, and I said, well, we'd have to set up a separate session. It can be done, but I said we've normally just brought people up 15 minutes or half an hour beforehand, and it's normally been all right. They've got the ropes quickly. So he seemed to accept that. And I said, well, I'll be logging in half an hour beforehand. He said he'll log in 15 minutes beforehand.
Are you guys hearing a noise? I think probably we should all mute off unless we're talking.
Sorry, Franklin, I am hearing a noise. What did you say about it?
Yeah, there's like a garbled noise going on. So
that may be due to me. I'm trying to set up something here.
All right.
Okay.
We didn't have that before.
Well, I'll mute you for a second, Nick. No, it's still there. I muted you, and it didn't make any difference, so it's still there.
Okay, good point.
So, Franklin is muted at the moment. I'll just say, is it Jim? No, it's not Jim. Bob is muted. Dennis is muted, and Franklin's muted. So it's gone.
It's good. It's gone.
Okay, I don't know what's happening. So, by the way, if any of you in the comments want to make any proposals, just please pop them in the note, and I'll look at them. But we have an option of maybe discussing bijection or other mapping elements, or perhaps looking at one or two of these videos. Sorry, I think
one thing my video does. Hello.
Yeah, sorry, Nick.
Hi, this is Jim again.
What's your video?
One thing my video demonstrates is that there is a large body of data available from various highly funded labs around the world, which is online, which people can download and do their own analysis on this data. For example, I've done in the video I have triggered, if you want to play it, is my analysis of the lunar laser ranging data for the moon, and also the GRACE satellite data, okay? And so that oftentimes the data that investigators post and is downloadable can be analyzed from other points of view to test other hypotheses which the original principal investigators who collected the data did not have. And for example, in my gravity work, in this video that I have queued, if it comes to showing that, what is remaining is the GRAIL data to download and to further confirm my results from the first two, the lunar laser ranging and the GRACE satellites. The GRAIL satellites were a pair of satellites put around the moon to look for, to make measurements of gravity, and the surface temperature hypothesis, which my analyses confirm, might be confirmed there also. So there's plenty of opportunities for investigators without huge budgets, but just a laptop, can download data and analyze it themselves with respect to a hypothesis that the original principal investigators did not have. So that's an important point that I think should be communicated to everybody, that oftentimes we feel, well, if we don't have a big budget, certain experiments can't be done. Well, in many cases, the data is so complete and different variables could be analyzed and in a way that the principal investigators never did in the first place.
How long roughly does this first video take, Jim?
Well, it's a 25-minute video, sir.
Yeah, because I'll tell you, I'm guessing now, but Amrit said to me, "Oh, he'll log in at 3:45." Now he's an hour ahead of me, and I thought he meant his own time, which would be 2:45. But I have a feeling that he might have meant my time, so he might be a bit mixed up. He's an hour ahead of me, as I say, but he might be logging in about half an hour's time to do a test. So we'd have time to put up that video. Indeed, he's not in now, and that may be the case, Jim. So if you'd like to roll it, we can pop it up. I have to.
Okay. Let me see if I can share my screen here. Video file.
Sorry to interrupt you, Jim, but Amrit has appeared. Just now, just this minute.
Great. Okay. Wonderful.
Okay. Right. We'll remember what you've said. So good afternoon.
Okay,
Good afternoon.
We thought you'd this hour difference between you and me.
No. Everything is fine. I didn't get the right link. Now you send me right link, and now I think it's okay.
Okay. All's well that ends well, as we say, quoting Shakespeare.
Yes.
So that's great. So what I did is I made I'll bring Jim down because James Keane was very kindly going to step in because we thought you might be coming in about half an hour, Amrit. So am I pronouncing your name correctly? Amrit Srečko, Professor Amrit Srečko. Excellent.
Yes,
Right.
very good.
Okay. So and I introduced you as being from the Bijective Physics Institute, a stationary cosmology initiative, which I believe you actually founded.
Yes,
in
yes.
Ljubljana in Slovenia.
It's true, yeah.
And you're going to be talking about bijective physics with some material in relation to cosmology interspersed.
Exactly.
Okay.
Yes,
Now, do you have some slides? Do you, Amrit?
I prepared this just to explain what means bijective physics, because this is a principle of research that just came into my mind 10 years ago, that every element in the model must have a correspondent element in the physical reality.
Yeah, one-to-one. So are you happy if we hand over to you and you can hold things like that up to the camera? Or do you want us to, be able to project your PowerPoint slides?
No, I think that's perfect. Because actually, what I see when I have such conferences, if there is too many slides and everything, there's too much stuff.
Yeah.
And I'm using a very precise but very simple language, so people will understand.
That's fine. Avoid death by PowerPoint, which is being called. So what I'm going to do is I'm going to hand over to you. I'm going to bring myself down and, just shout if you need any more assistance. We have myself, and we also have Franklin who's assisting us here on the technical side.
Okay.
And you can have as long as you want. I mean, if you want an hour, that's fine. If you want a bit, 50 minutes is fine. If you want more than an hour, that's fine as well. So
1 hour will be perfect, because in 1 hour I would like to explain the basic principles of research methodology and how we apply this on cosmology, and how we have seen that actually a Big Bang is not falsifiable theory. It's all made up.
Well, that would be most exciting to hear that aspect of your research. And I didn't explain it, but I'll say it now that we'll have maybe almost 3/4 of an hour after you finish speaking for questions and answers and discussion. Now, the people in through the social media, the Facebook and the YouTube, will have questions here which I can put up and we can address them maybe. There are about 5 or 6 people in the green room, and I'll be bringing them up, or they can wave their hand, and that'll mean they want to get up. But even if they don't do that, I'll possibly bring them up if we have time, and we'll have a
That's
more
very good.
one-to-one discussion.
That's very good.
So without further ado, and we'll only interrupt you if there's such an emergency, if with your permission, if we don't understand a word you're saying or something like that. But I think that's very, very unlikely. So the idea is that you will have up to an hour uninterrupted presentation, and we'll come in later.
Okay.
Okay. So
Okay.
So the floor is yours, Amrit. Thank you very much indeed.
Thank you, Jan. So I am very happy to be introduced here at this channel, that I can talk about bijective physics and how we apply bijective research methodology into cosmology. So the main this happened to me because I'm reading theoretical physics articles for last 30 years, and I've seen that by time I understood less, not more, and it was strange to me. And then I've seen in theoretical physics we have a lot of models which have exclusively mathematical character. That means that mathematical physicists are dealing with some elements which we are not sure they have some physical correspondence in physical reality or not. Somehow, with the beginning of 20th century, with the special relativity, mathematics has overruled physics. And I've seen this, and in a few months, I got idea, which I think it's quite a good idea, to develop a new research principle where I call it bijective research methodology, where we have, you imagine, we have two functions, two sets. We have a set of the universe, which is X, and we have a set of the model of the universe, which is epsilon. So in this research methodology, every element that we have in the X, in the model, must correspond exactly to one element in physical reality. This is a basic principle which is very clear. And when we study this model, so-called space-time model, we have seen that actually space-time model has no bijective correspondence with physical reality. We are now in physics, we are convinced for 100 years that time is fourth dimension of space. But we do not have any evidence, experimental evidence that this is true. So in special relativity, we have this famous equation x4 x ICT. We have this famous equation. And if we look at this equation, we see that the product of light, speed, and time is distance. So x4 is distance. Okay, here we have also imaginary number, but actually x4.
Sorry, Amit, just a second. Sorry to interrupt, but I've just been asked that when you put something up, if you could leave it up for much, much longer, you're taking it away too quickly, so they complained a bit.
Okay.
Thank you very much.
Thank you. Thank you, Anne. Thank you. So x4 is imaginary number per light speed per time. This is from special relativity. And we can see that in this equation, x4 is not time. x4 is dimension, is spatial dimension, which is imaginary, but is a product of imaginary number light speed, and time. So having in the mind, let's say in the mind of the physicist, that time is something that universe exists in time is wrong. Universe does not exist in time. Universe exists only in space. And we published, I think 2 years ago, an article in World Scientific. We introduced this new model with the time invariant space, which means that the universal space is time invariant. There is no past and there is no future in the universal space. In the universal space, we only can perceive change. And we measure duration of change, we measure with clock. So time in physics is duration. But we have to understand that duration enters existence when we measure it. If we don't measure time as duration, time does not exist. So universe is utterly timeless. And time is an emergent physical quantity that enters existence when the observer is comparing motion of clock with the motion, let's say, of the atom or of a material physical object in space. Time is a byproduct of measurement. This is very important to understood. Actually, Einstein used to tell us there is no past, there is no future. For us physicists, which we understand physics, there is no past, there is no future, only present exists. Also Schrödinger, he had the same opinion about time, that only now exists. And this now, actually, what we experience as now, this is the only physical reality that exists. The problem of the 20th century physics was that we have been, or they have been, experiencing this through the linear time that is in the brain. And Buhusi, a neuroscientist, and later on few others, they publish articles that linear time, past, present, future, has physical basis in the neuronal activity of the brain. So this linear time for which we think that it exists in the universe, actually that universe exists in this linear time, this is a misunderstanding, because linear time exists only in the brain. And we experience, let's say, motion in the space through the psychological, neurological time, and so we experience everything in time. But this time is running inside, in the brain. This happened to me back in 1982. That actually once I went in the mountains. It was beautiful time, beautiful moonlight, and suddenly I lost this experience of linear time. So I was very interested what actually happened to me, and I intensively start studying relativity theory, especially at the beginning, special relativity. And then I've seen actually that this experience, my experience of this strong now, which is the only thing, the only reality that exists, is something that is true. We published several articles on this. One article we published years ago in Foundations of Physics. We published few articles in Physics Essays and some other journals. One article also with Springer, Entanglement, New Understanding of Entanglement and Time. Maybe this is very interesting. I would like to put this out before we go into cosmology, because just recently they asked me to review an article about this. We cannot properly understand entanglement, Einstein-Podolsky-Rosen type, in the frame of the space-time model. This is a problem now for 100 years, but once we understand that Einstein-Podolsky-Rosen experiment, we have two particles, they go each other, one in this side, other in this side, and they know each other's spin. This is because this time invariant space has a higher ontological level than particles, which actually are energy structures of the space. So the space is knowing about the spin. It is not that there is some information running between the particles, and some physicists, they are now introducing kind of, I think it's not a good idea, infinite speed. The speed can always be only finite, because infinite speed plus 100 miles is still infinite speed. So infinite speed is not a physical term. This is mathematical term. In mathematics, we deal perfectly with infinity. The problem of infinite numbers is solved, and but applying infinity in physics, I think is not a good idea. So they try to explain entanglement with infinite speed, which is, I think, wrong. The space actually knows about behavior of particles. And as in the universe, there is some basic symmetry. If one particle has a left spin, the other will have a right spin. But the information about this is in the space, has nothing to do with the particles. It has to do with the particles, but there is no information running between the particles. In the model that I developed in last years, actually, this universal space is not only four-dimensional, as suggested by Einstein, is n-dimensional, and is also complex. So we developed a mathematical model of a complex n-dimensional space, which has many, many layers. And the n-dimensional layer of this universal space is consciousness. So consciousness is the basic reality in which everything exists. And because of this, let's say also entanglement is something that is working. Actually, the entire universe is entangled because the universe exists in this eternal now. From this point of view, the idea of the beginning of this big explosion doesn't fit anymore, because what we can read in textbooks of physics and what we are still teaching students at universities is that time has started with the Big Bang. Before the Big Bang, there was no time, there was no space. We do not know what was. this view, from my perspective, is not a scientific view. This is religious view. Big Bang theory is a kind of religion. And the Big Bang theory, from this point of view, is not falsifiable. You cannot prove it, you cannot disprove it, because this is not scientific theory. The huge problem, Big Bang theory has many, many huge unsolvable problems. One problem of Big Bang cosmology is expanding of the space. NASA has measured back in 2014 with very high, very high accuracy that universal space has Euclidean shape. Universal space has not Riemann shape, it has Euclidean shape. What does it mean? The structure of the Euclidean space is such that when we have two distances, 2 points, we have in Euclidean space 2 points, okay, A and B. The matrix of Euclidean space is such that the distance between 2 points in the space is always constant. It cannot become bigger. It cannot become longer. It cannot become shorter. This is possible in the Riemann geometry, when with the increasing of the radius of the matrix, the distance between 2 points is increasing or decreasing. But this is not the case with Euclidean geometry. So NASA has concluded back in 2014 that universal space is infinite, which means that the universe is infinite. So this idea of beginning from mathematical point that was developed by Stephen Hawking, I think this idea is false. What Stephen Hawking has published this in a very important journal, and he say the energy of the matter is positive, and the energy of the gravity, which means the energy of the space, is negative. So he used to say that energy of matter plus energy of gravity, energy of matter and energy of gravity is always zero. Yeah? And you say at the beginning something happened that these two energies get multiplied, but the sum is always zero. This is also not a scientific point of view, because the energy cannot appear out of nothing. First law of thermodynamics, energy cannot be created and energy cannot be destroyed. It can only be transformed. The next problem that was never mentioned in the Big Bang cosmology is they are saying that the gravitational redshift is the proof that universe is expanding. The gravitational redshift was very good explained by Swiss astronomer Zwicky. He called it tired light effect. So what actually is happening, that the light that is coming from distant galaxies has some energy loss. And this energy loss is because the light is pulling out of the strong gravity of the of the galaxy. And when the light is pulling out of the strong gravity, the light is losing some energy, which appears to us on the Earth as redshift. And this was measured on the Earth. We call this Mossbauer effect. The gravitational redshift is not proof that that universe is expanding. It is only proof that light, when it's moving away from the galaxies, is losing some energy. Also, the Doppler effect, which is well known in physics, we measure the Doppler effect on the Earth always in the stationary space. No? So when the source is moving away, you get longer frequency, higher frequency, longer frequency. When the source is moving close, you will get stronger frequency. And we never observe Doppler effect in the expanding space. So interpretations of astronomical observations regarding gravitational redshift are wrong, in my opinion. The next thing is cosmic background radiation. The official explanation is that this is radiation from the period after the Big Bang recombination period. But this is only a hypothesis. This was never proved. The cosmic microwave background radiation is radiation of the entire universal space. This is what we observe. That entire universal space has this type of radiation. Because no signal could come from the physical past, because physical past does not exist. So again, by cosmic microwave background radiation, this is a wrong interpretation. Cosmic microwave background radiation is not proof for the Big Bang model. It's proving that entire universal space is emanating this type of frequency. What we see, actually, the model of cosmology that our research group has built is based only on astronomical observations. We don't have any theoretical propositions. Let's say there was a huge explosion, or let's say universe is expanding. We don't have any propositions. What actually I decided years ago, we will develop a cosmology model only on astronomical observations. And one very strong astronomical observation is that we have these huge jets that are coming out of the most of galaxies. In the center of the galaxies, they are huge black holes, which they throw out these huge jets of energy. It is not clear yet exactly how these jets appear, but this is well documented and was published in very important journals. So the existence of black holes in the center of galaxies and of the jets is not anymore questioned. This is scientific fact, well observed. What actually happened in the black hole? This is essential question for cosmology. What happened in the center of the black hole? What happened in the center of these huge black holes in the center of galaxies? Professor Roger Penrose has published years ago an article about infinite curvature of space in the center of the black hole and about gravitational singularities. He got a Nobel Prize for this, I guess 3 years ago. But there is a huge problem here. The problem is that just here I see no singularity black holes. Yes. The problem here is that infinite singularity, first, is not a physical term. And the second, we know in Newton physics that for the physical objects, a Newton shell theorem is valid. That means we have, when we go closer inside to the center of the given stellar object, when we go closer inside, when we go to the center, the gravity force is less for the part that is above a given point. Yeah, this is Newton's shell theorem. Everybody knows this. So the fundamental question is why Newton's shell theorem would not be valid for the black holes. There is no reason for this. And I did several calculations which show that in the center of the black hole, the energy density of space is extremely low. And because energy density of space is so low, the atoms become unstable. I will write now the formula. This formula is the extension of the mass energy equivalence principle on the universal space. Here we have a Planck energy density of universal space, which is actually this superfluid quantum vacuum, as we call it. This is in the intergalactic space. And here is the energy density of the space in the center of the given stellar object. And here is the volume of the object. I was searching for the formula that would describe a relation between a given stellar object and surrounding universal space for many, many years. But once this equation, when I gave up already, actually popped to my mind. And it's a very useful equation, which also works in the relativistic domain. What is important here to understand that replace space-time model with the time invariant superfluid space, where space is a fundamental energy of the universe. And this energy has a certain energy density, which is a Planck energy density in the intergalactic space. In the center of every physical object, this energy density is diminishing exactly for the amount of the energy of the stellar or physical object. This is this equation again. This is extension of the mass energy equivalence principle on the universal space. And the calculations are showing that in the center of the black hole, the energy density is so low that atoms become unstable. We have to imagine this. Let's say if we would stand on the raster on something that we would have, let's say here, 10 centimeter distance, okay, 10 centimeter. There would be no problem. We would be still stable on this. But then something happened, and these distances would grow. When the distance would be 1 meter, we would fall through. Something similar happened in the center of the black holes, because the energy density of superfluid space must have a certain level, otherwise the atoms become unstable. The theory of the vortex model of elementary particles was developed by several physicists. And what does it actually mean? That the proton and the electron are vortex of superfluid space. And this vortex, in order to be stable enough to keep together atoms, need a certain energy density. So in the center of the black hole, the energy density is too low, and the atoms are falling apart into elementary particles that are then thrown out in these huge jets. The black holes are rejuvenating systems of the universe. The black hole is eating its own material and throwing it out into the intergalactic space as a fresh energy. And out of this fresh energy, a new galaxies are born. So in our model of the universe, there was no beginning. This transformation of energy in the black holes, when the old matter is transforming back into the fresh energy, this is eternal process. There was no beginning. If we go back for a moment to the Professor Penrose's model of infinite curvature of space in the center of the black hole, and consequently gravitational singularity, Einstein's idea that space has a curvature, actually, it was a good idea, but with some weak points. And the weak point is that this is a mathematization of gravity. This is geometrization of gravity. But as NASA has discovered that universal space has Euclidean shape, we cannot discuss today anymore or build physical theories where we use curvature of space, because there is no such a thing. And Penrose's model does not explain these jets. Penrose's model is a mathematical model, and I think it's not right. So in the model that we developed, the model of cosmology that we developed, there is no unsolved questions. Everything works properly, and we can explain everything what actually is observed in astronomy. One thing that this is called bending of the light, gravitational bending of the light. Some astronomers are saying that this is a proof that space is curved. This is not right. Light is bending when light, let's say the galaxy, let's say our sun, when light is passing our sun, okay? When light is passing our sun, light is entering the area of the superfluid space when the superfluid space is getting more dense. And when the light is going away from the sun, when light is approaching close to the sun, the energy density is getting lower. When the light is moving away, the energy density is increasing. And because of this, the light is getting refraction. We have refraction of the light. So this is only because of the variable energy density of space and has nothing to do with the curved space. There is one thing more which is extremely important. Dark matter problem now for 80 years is not solved yet. And recently, in the last 2-3 years, we can read different articles that actually dark matter was not found and probably with high probability does not exist. We know very good why dark matter was proposed. This missing matter, which would explain the speed of rotation of some stars around the center of galaxies, this is 80 years unsolved problem. We have solution for this. An article will be published recently because we imagine that, that this is a huge black hole. Let's say Sagittarius in the center of our galaxy. And this black hole is rotating. Some black holes are rotating with a very high speed. Rotation of the black hole also start rotating the superfluid space. And that's why the stars which are rotating around the center of the galaxy have a higher orbital velocity as it should have accordingly to the Newton physics. The same is happening in our solar system. The Mercury precession happened because the superfluid space is rotating around sun. And so the planets are, let's say, every rotation are a bit farther than it should be. So the superfluid space model, this time invariant superfluid space model, where we have a variable energy density, is a powerful model that is advanced in the sense that is a very close to the physical reality, because it is based, as I started on the beginning, it is based on the bijective research methodology. The idea of empty space has has stopped development of physics for more than 100 years. As far as I know, that this was actually Einstein's idea when they throw ether out of the physics. Einstein say the photon can move through the empty space. But the empty space, from the phenomenological point of view, is an empty term, doesn't mean anything. There is nothing in a physical reality that would be empty space. Such a thing does not exist. And I remember years ago, we have been fighting with one journal for 1.5 years because we claim in our article that space cannot be empty. And the chief editor told us that that physics is study particles and fields that exist in empty space. I believe here that the big minds of physics of the past century, some of them have not been well understood. I like very much this quote of Schrödinger, which goes like something like forces and particles are different structures of the space energy. I have 4 minutes more. I will use these 4 minutes to explain a few other things in our model. My vision for the last 20 years was to integrate evolution of life into cosmology. Because we have now in science, we have cosmology, we have evolution of life, then we have human sciences, but universe is one, reality is one. So my idea was to integrate natural sciences and human sciences. And recently we published an article where we integrate evolution of life into cosmology. What I measured, I think 35 years ago at University of Ljubljana, that the gravity works with a stronger force on the organism when the organism is alive, but when the organism dies, the gravity force is becoming weaker, is less. Why is this? Because what David Bohm, he used a term, implicate order of the universe. This implicate order of the universe is, in my opinion, in my view, is an information basis for the development of life. So the intrinsic information that lives develop is in the entire universe of space. Information is always there, was always there, will be always there, if I say in the old style. And this information for the evolution of life has some physical properties. These are different type of energy. This is not electromagnetic radiation. This is more subtle type of energy, which we call bioenergy or chi or prana or consciousness. But the presence of these energies in the living organism is increasing weight. So I'm very happy that you give me a possibility to talk today because we are now searching for some institute in the world that would repeat our experiments with the worms. I repeat experiment 5 years ago again, and what we find out that when we weight, we have on the precise balance in the mass closed system, sure, we have 1 gram of worms. When these worms die, the weight is less for 5 micrograms. This today is measurable. The balances today are developed to the level that we cannot imagine. I did that on some MATLAB Zurich balance back in 87, 90 at the University of Ljubljana. And if someone from the public, from the people that are listening to this video, have possibilities to repeat this experiment, this would be very, very good, because this would be scientific proof, actually, that our reductionist principle of science, that only things exist which are measurable, somehow we have been excluding 95% of reality out of the scientific picture of the world. The ideas that consciousness is based on the neuronal activity of the brain, I think that this idea is wrong. Consciousness and the higher cognitive abilities of human beings are far beyond electromagnetic level of energy. This is something very, very, very subtle, let's say, empathy to the other human being. This is something very subtle, which also definitely has some energy substance. And we have been measuring that this, let's say, subtle energies that are in the human being, and also that are which are also in the living organisms, they have some impact on gravity. So this would be the end of my presentation. I've seen here on the right some questions, but I was not able to talk and to read this on the right side. But now I'm here to discuss and to answer all the questions that you have. I hope that most of them I will be able to answer properly. Thank you very much. Jan, I don't hear you. Jan, you don't have a... Jan, you don't have microphone. I don't hear you.
Can you hear me now? Can everybody hear me now?
Now I hear you now. Good. Yes.
Okay. Sorry, my fault. Right. Well, thank you very much for that most stimulating exposition of your system. And don't worry at all that you haven't been able to capture all the comments that are coming in on the social media. I haven't been able to do that either. But between myself and Franklin, we'll try to pick out any that were genuine questions rather than just to and fro conversation between the participants, and maybe put them to you. And I think there are a number of people in the green room who will want to say a few things as well. So we have plenty of time. We have about 55 minutes. But maybe just a couple of comments, if I may, at this stage. Actually, I was quite interested and surprised to a certain extent that using your principles of this mapping, this bijective system, you reached a number of conclusions which many of us, certainly for my part, I have reached similar conclusions with regard to things like Wiki's tired light, infinite universe. Actually, it was interesting that our presentation to Glenn Borchardt last week was about his central thesis that the universe is infinite in space and time, and things like cosmic microwave background radiation, the problems with curved space and so on. Just maybe before handing it over to the more general discussion, just one or two quick points. I'm not sure if I understood completely your point about reaching the conclusion that the speed of orbit would increase with increasing distance away, thereby perhaps obviating some paradoxes.
You mean
Did you say that came out of Newtonian?
you mean the problem of the missing dark matter?
Yeah, dark matter has been introduced to explain that anomaly. Indeed, yes.
Yeah, when the central black holes in the galaxies are rotating, and because they rotate around their axis, they also rotate the space around them. This is the same if when you put in the water a round ball, it will start rotating water. And this superfluid space is a kind of energy that also is related with the objects that are moving or rotating in the superfluid space. So when the central black star is rotating, the entire space is rotating. And that's why the stars have a higher orbital speed. And the one part of the orbital speed is Newton's calculation, and the other part is this rotating superfluid space, and this part was never calculated. We have now article in the peer review where we calculate this, and there is no need for dark matter.
Oh, okay, so it's a drag effect, but you
It's a
are
drag effect.
you are accepting, are you, the existence of black holes, that sort of theory? Because you've questioned a lot of the other Big Bang business, and I think justifiably so.
As far as I follow astronomy, I think that this, for me, this is not a question that the black holes exist. But what has happened at the beginning of the black holes research, that the entire thing was very mysterious, this event horizon and all this stuff, which is a kind of mysticism which is not necessary. The black hole is a star that has such a density of the matter, of the material, that in the center of the black hole, the density, the energy density of the space is so low that atoms become unstable. So the black hole start eating itself. It's not that the black hole is this idea that the black hole has a tendency for the gravitational collapse. It's not a gravitational collapse that black hole would just vanish into nothingness. No, black hole is eating its own material and throwing it out into this huge jets of energy, which are actually well presented in astronomy. There have been articles about this, I think even in Nature, some articles. So it is difficult to say that the black holes would not exist, in my opinion.
So they're a bit of an extension of other physical phenomena, that cause collapse in stars, to things like neutron stars or white dwarfs. It's really an extension, which is more physical than this sort of, almost like ideological idea of a black hole, which doesn't seem to have physicality, and indeed would contravene bijectivity, if I may say so. Okay. There is
this idea of Professor Penrose that the curvature of black hole in the black hole is infinite. This idea has no physical meaning, and the idea then that the gravitation there has singularity. This has no physical meaning. This is only a mathematical model which has nothing to do with the real situation in the center of the black holes. And I was very surprised that the Nobel Prize was delivered for this, because there is absolutely no data, astronomical data available for this model of Professor Penrose.
Okay. Now, Nick, I'm just going through the questions quickly, and I haven't got anything specifically that I've put up. But Nick Percival has signaling to me. So I'm going to bring you up now,
Yes,
Nick,
yes,
and
yes.
you can pose your question or discussion to Amrit. Go
Hi,
ahead, Nick.
Nick. Hi.
Hello, Amrit. So
Hi,
glad
Nick.
you could make
Finally,
it. I
finally.
really like that presentation. I think it's my
Thank you very
favorite
much.
of all of the Saturday morning ones. The only thing that was disconcerting to me was that you speak English better than I do, and English is my only language. But anyway, we'll forget that for the moment.
No, don't say this.
Just on the point that you were talking about, I agree with Amrit on this, but this is a point about terminology. A black hole, by definition, when it has a certain amount of mass, by definition has a singularity at the center and event horizon. So basically, we need to invent a new term for what your view of these dark, dense objects are. Because
Yes.
your view, which is better than the original view of a black hole, is a qualitatively different object than what is known formally as a black hole. In other words, it's just a different definition of making sure that our terminology is in sync. Because when it says black hole to somebody who's deep in currently accepted theory, they think of an object with a singularity at the center. And I agree with you that doesn't make any sense at all. So we throw away black holes and come up with some other term. Very dense dark matter. Dark matter dead, but very dense matter.
The black hole actually probably was introduced as a name because the light cannot escape back. But also this is not true. But what I have seen, that the black holes have been very a kind of mystery. Also, you can read in New Scientist, Scientific American, something mysterious. What happened inside of black hole horizon and all this stuff. This all is just a unnecessary complication, because with the extension of the mass energy equivalence principle on the universal space, which is superfluid, we develop a relation between every physical object and the space. And in the center of every physical object, energy density of space is lower exactly for the amount of the energy of the physical object. There are some stars in the universe, there are many, where energy density in the center is so low that atoms become unstable. And we can also explain with this model supernova, because when we have a black hole which starts eating its own material, what happened? That inside, in the center of the black hole, there is a huge amount of energy, of fresh energy. And at a certain moment, the pressure is so huge that the star will explode. This is supernova. In the case that, as we have in the many, in the center of the many galaxies, is that the shape of the black hole is like this. That black hole in the center is empty. How this happened? That we know that the black holes has such a elliptic shape. So when the pressure in the black hole was increasing at a certain moment, but the black hole was too big to explode, at a certain moment, and in the direction of the rotation, the pressure was so big that the black hole make a hole through. And this is now the case of the black holes that we have in the center of galaxies, that through this open space, these huge jets of energy are thrown out in the intergalactic space. So there is no mystery. There's no mystery here.
Okay. Now, Bob Gray, yes, has been signaling. So I'm going to bring Bob up now. Bob, I think, had a number of little points in the chat, which I may not have picked up totally. So you're up now,
Hello.
Bob. Go ahead.
Okay, thank you. Thank you for the presentation and discussion. It's very interesting. I'd like to go back to the beginning where you were talking about time. And I'm not sure I understand your concept. I thought I heard you say there is no time, there's only space. But then I start questioning, well, then how do you define change? You know, something changes. It could be a chemical reaction. It starts in this state and it evolves, but you can't evolve if there isn't time. So I'm wondering if you could clarify this idea of or your idea of time and how it's connected to change.
Yes, definitely. Yeah, thank you, Bob. Look, we are now having discussion for 1 hour and 16 minutes, and we are all getting older. There are biochemical reactions in our body. We are getting older. But do we have some evidence that we are getting older in time? No, we don't have. We have evidence that we are getting older in space. When you walk on the street, you do not have evidence that you are walking in time. You only walk in space. And time is duration of your motion. So nothing ever happened in time. The problem is, not a problem. The fact is that we are experiencing change through the linear time, past, present, future, that is in the brain. But you can train yourself, you can step out of your psychological time. And then it will happen to you that you will live only in now. I mean, to me, happen for 30 years, it's always now. I mean, maybe funny, but for me, it's now, because I don't have this experience of linear time anymore. Also, Einstein happened this. Also, Schrödinger happened this. There are few people, physicists, that have this experience, that actually time is not physical. In physics, in Newton physics and in quantum mechanics, time is a mathematical operator which is showing us duration of certain physical event. And this mathematical operator we create when we measure, when we compare motion of clock with whatever. But if we don't measure, we don't have time, not even as a mathematical operator. So time is invented by the observer.
You can't
in order
base it on
to
humans.
Yes.
Sorry, what's that, Bob?
I don't understand why it would be based on humans. What about flies? What about a chemical reaction? What about those things that all change? They change. It doesn't depend on my brain perceiving a linear thing. It doesn't depend on my watch. It does. These things are independent of humans and human consciousness. There are change independent of human and human consciousness. Isn't that change a kind of realization that time exists?
If we follow the results of neuroscientists, you can see many articles that the linear time is based on the neuronal activity of the brain. But even if we leave this out and we just discuss now, in this moment that we are here, I would ask to you do you have any evidence that physical time exists? We have evidence, let's say, that this physical object exists. I'm moving this object in space. We have evidence that space exists because the object is moving, is changing position in space. But do we have any evidence that this object is moving in time? If you have it, tell us.
Well, chemical reaction. I set up a beaker, put something in, I go away, come back, it's in a different state. It has changed. And it doesn't depend on me.
Yes, it doesn't depend on you, but you have no evidence that chemical change has happened in time. You don't have any evidence. You only have evidence that change has happened in space. And what when you can measure duration of chemical change, and then you say this has taken 30 minutes, and that's all.
This can be argued to be a very philosophical question, really, I mean, I have a degree of sympathy with the view Bob is expressing, but I also see the view that Amrit has put forward, and it's similar to, I think, the view that Nick Percival has, that time is essentially unreal. And then we're getting into the whole area of idealism versus realism. You were, I think, hinting at that we were almost thinking that it was a human construct, and if it were not perceived by humans, it didn't exist. Just like a tree in the forest, if it's not observed, doesn't exist. But for my own part, I find this discussion very, very interesting.
This is very important.
When I'm solving partial differential equations classically, I use x, y, z, t. And actually, even in regard to using things like light moving out from a spherical point, I sum coordinates x1, x2, x3, x4. And as you said, x4, ICT. If I square that, I get the the distance that light has traveled. I'm not talking about accepting the Lorentz transformations of special relativity. I'm talking about using it as a coordinate and then maybe interpreting that thereafter. So maybe we can come back to that. And actually, I do note, because you sent me one or two papers of yours, a link.
I've sent you everything.
Yeah, those might be worth.
Jan, you say something so essential that we are trapped in for 200 years or even more. I would like to point this out. If I look at the tree, okay, and I say, okay, the tree is here because I am looking at it. Then I turn away and then I say, the tree does not exist. This is something very different. This is idealistic philosophy from the fact that if I don't measure time will not exist. We humans, we observer, as a physicist, when you observe a certain experiment and you measure it with time, you create duration. That is something so powerful. Because if you don't measure it, does not exist. And you know why? Because we are living into eternal now and here. Duration is human invention. Sorry, but for me, this is funny.
Chemical reactions start and stop. That's a duration, and that has nothing to do with humans. Flies are born, they live, die through a duration.
Bob.
But I'm sorry, maybe I don't want to take up everybody's time on this.
Good. Let's give 1 minute more. The chemical reactions start and end. Okay, let's say, whatever you do, it starts and you end. But what is very important, if you don't measure, there is no duration. Duration enters existence when you measure it, because everything happened in this eternal now and here. There is no duration at all. Duration is real when we measure it. Otherwise, does not exist.
Right. Well, this is a very interesting discussion. It sort of reminded me a bit about the action or the response of Dr. Johnson, Samuel Johnson, when his biographer James Boswell, put forward to him Berkeley's idea of idealism, that something doesn't exist unless it's perceived, presumably by humans. Johnson didn't seem much interested, but Boswell said, "But you can't refute it." So Johnson was passing a lamppost, and he gave, without looking at it, he gave the lamppost an almighty kick with his foot, and he said, "I refute it thus." Anyway, so this is something we may very well return to, but I'm looking now. I was going to ask, and I see Nick wants to come in, but perhaps Dennis, we'll give Dennis an opportunity to come in. So I'm going to put Dennis Allen up. And Dennis, what's the point you'd like to raise? So no, can't hear you.
Hello, Dennis.
Can anybody hear Dennis? I can't.
He has
Wait, you're muted.
must-
You're muted. You've muted yourself, Dennis.
Now it's good.
No, yeah, but I still can't hear you. I'll tell you, Denny, if you don't mind, I'll put you down. I'll put Nick up and get his second point in, and you can sort of see, can you get that fixed up? I think it's your own sound. Just do a test. So, Nick.
Yes, I'd like
Nick,
to make a point about the last discussion between Bob and Amrit. And I'm 100% agreement with Amrit. I would just like to say something in a little bit different form. Duration exists, and we've always thought of duration as a property of time. But duration is a property of processes. What we've always measured when we use clocks or tried to measure time, we've never measured time directly. We've always measured processes. So what really exists is the process length measured in some inherent characteristic, like in stable processes, you measure the number of cycles or the number of revolutions. So when you thought you were measuring time and time was passing, all that was happening was that processes were proceeding. And the length of a process would be 97 cycles or 48 revolutions or something like that. It's just that we've become so used to thinking that time is the reality that we equate duration to time. But what we've always measured are process length, and duration is a property of duration is a property of processes. So all the properties of time are also properties of processes, motion, change, whatever, except for dimension. Processes don't have their own dimension. They unfold within three-dimensional space. The mistake that Einstein made was giving time its own dimension, as Amrit has pointed out. So you can still think in terms of duration and rates and whatnot, but just realize that we've always measured those in terms of this process or that process. So like the day was originally thought to be the time it took for the sun to go around the earth. And eventually we got rid of that mistake and realized that's the property of the earth making one revolution about its axis. And then the hour is defined as 1/24 of that, and so on down the line. And now we define a second as 9 billion, et cetera, cycles of cesium-233 or 38 at the base state. So now that should make everything crystal clear.
there is a small difference in your view and my view. In my view, duration does not exist on its own. Duration enters existence when you measure it. So we have been thinking in physics that duration is something that we measure with clock. No, duration is something that we create when we measure something, because everything in the universe is utterly timeless. We are living into eternal now that actually mathematically we described with this time invariant superfluid space, where there is no past, there is no future, there is not even now, there is only eternity. And universe is changing into this eternity. So we humans, we developed science to see universe and everything what happened in the universe from the scientific point of view. But we have to be aware that we are creating this scientific point of view. And one part of this creation is duration. Duration is human invention that enters existence in the process of measurement. We do not measure something that some existent duration.
Amrit, Bob Gray posted this in the private chat, and I've just put it into the public chat because he says, discuss your book, Relativity Reborn. Now, I think this might be interesting for us because we'd like to know your position with regard to the special and the general theories of relativity of Einstein, distinct from Newtonian or Galilean relativity, like how it fits in. Many of us here obviously would be relativity skeptics, and I mean Harry has been posting some comments, and I might bring him up in a minute. But Harry Ricker has been posting some comments to saying that the very existence of black holes and all that, and the very fact that relativity contravenes bijectivity would discountenance it. So basically, what's your position on this, Amrit?
Yeah, I checked that. I've seen that. Special relativity and also general relativity, these are not physical theories, these are mathematical theories. And we publish about 10 articles about special relativity. Special relativity, until these days, is not well understood. We did not use Lorentz transformation. We used Galilei transformation for x, y, and zeta. And we use Celeri transformation, Italian physicist Celeri, for time, for duration of time, for time as duration. So what is the point? This crucial thing that we all have very good in mind. I am on the station and Ian, you are in the train. So for me, your clock is going slower, and for you, my clock is going faster. This is the usual interpretation of special relativity. But this is not exactly what is the meaning. The truth, the fact is that both clocks are running with a certain speed, which is valid for you and which is valid for me. Because the relative speed of clocks in special relativity has nothing to do with the observer. Is the result of the variable energy density of space. If space is more dense, or let's say where space is more dense, the rate of clocks is higher. And as the train has a certain kinetic energy, if we recalculate this kinetic energy, we will see that this kinetic energy has added that the energy density of space is a bit lower. And that's why the clocks run a bit slower. And this is proved by GPS system. Because of the special relativity, clocks are running faster for 7 microseconds per day on the satellites than on the Earth's surface. And for the general relativity, the clocks are running faster for 45 microseconds. So the result is that clocks are running faster for 38 microseconds on the satellites than on the Earth surface. So the relative rate of clocks is related only to the variable energy density of space and has nothing to do with this idea of Einstein that this depends on who is observing and from where you're observing.
But certainly, Amrit, you've talked about atomic clocks, which are used in these
yes.
experiments. What one doesn't know that if one used other forms of measuring the elapse of time, that there would be the same speeding up and slowing down.
We can use clocks that we want. Every clock will run faster in the intergalactic space.
Well, how do you know that? Would be, I think, the question that many people would put. We know that atomic clocks do, and possibly that's due to some vibrational change, with either gravitational potential or with velocity. But if you had a means of measuring time in another mechanical way, I mean, perhaps if you had a sort of like a gravitational type clock, as it got further away from the Earth, it would be the opposite. It would go the opposite way. It wouldn't speed up. It would slow down.
These are somehow facts on which GPS is working. The clocks on the satellites definitely are precise clocks, but they are running differently than on the Earth because of two effects: special relativity effect and general relativity effect. And we cannot almost, I mean, in my opinion, it's difficult to discuss this, because when you are in the car, your GPS is working on that system.
Yeah, but again, it's a bit of a question of terminology, because many people would say that no, they're not special and general relativistic effects. They are effects, physical effects on atomic clocks.
Yes.
Which, yeah. So
it
happens that in this instance, the general and special relativistic formulae, which they apply to all clocks, concur with this. But does that? Well, it's a bit of a question as to. Many people would say it doesn't actually establish.
Jan, if you would,
with your permission, yeah, go ahead. Do you want to say something more?
We have this, let's say, this twin problem. Twin problem at all, because if I would have a twin, and twin would go on the moon. Right. On the moon, the gravity is not so strong than on the Earth, and that's why on the moon everything runs a bit faster, because universal space is time invariant, and the speed of changes, biological, chemical, clock rate, whatever, depends on the energy density of superfluid space. When the space is more dense, the velocity is a bit higher. We calculate all this, and if the clock would be in the intergalactic space, because the density there is at the maximum, is a Planck energy density, they would have a slightly bigger rate.
Well, yes. I mean, I've been discussing how one might come to this from various angles, maybe somewhat differing from yours there. But somebody like Harry here has put in the comment, it's a private chat, I haven't transposed it, but he said his view, I think, and I'm going to bring him up to substantiate this in a moment, but he seems to be saying that the absence of bijectivity in regard to special relativity in itself disproves it. Now, however, having put that bomb out, I just want to check for courtesy, really, if Dennis has been able to get his audio working. Have you been able to get?
Yeah, it's working.
Dennis?
Yeah.
I thought I heard you there. No.
Still something doesn't work.
You see, I think it must be his own system, because I've unmuted him here, just as I've done with all of you. The video is excellent, but the sound is just non-existent. So, if you'd like to put your comment in the chat, I don't know, maybe it's something which isn't short, Denny, but I'll maybe allow you to do that in the private chat, because you're in the green room. I'm sorry about that. We better get that sorted out. So if Harry would permit me, I did quote him, and I may have been inaccurate. I may have been accurate. I may have been partly accurate. But I'm going to add you to the stream, and you can make your point, Harry, to both of us, in particular to Amrit, and maybe discuss this question of relativity.
Well, basically, all right, I'm just going to say this. I think a lot of confusion. The bottom line is that current science is interpreting cosmology and physics based on special relativity theory that's incorrect. And general relativity is based on special relativity, so it must be incorrect because special relativity is incorrect. And the reason special relativity is incorrect is because it's not bijective mathematically, which means there is no uniquely true result that can be calculated in special relativity. So it's wrong. And all of our physics is based on special relativity, and special relativity is wrong. Therefore, all the BS about cosmology and black holes and all these other things that you said is wrong too. So you're right. It's all wrong.
Harry, you are very tough. I mean, you are right regarding the fact that the special relativity is not respecting the principle of bijectivity. Once we apply bijectivity on a given model, automatically the model is also falsifiable. But the special relativity, I think, is not completely wrong, because as I said before, this special relativity effect with the clocks on the rate of clocks on the satellites, but the special relativity enters some contradictions because it is not bijective. One contradiction is you have an inertial system in which you have two clocks, two photon clocks. One is vertical and other is horizontal. You have in the inertial system, you have two clocks, one is vertical, other horizontal, and you increase the speed of this system. What happened? Because of the length contraction, because of the length contraction, the clock will get shorter and will show different time than the vertical clock. But we do not have in special relativity possibility that in the given inertial system, two clocks would have a different rate. So definitely special relativity is contradicting itself, and applying bijective methodology, we built up a special relativity and also general relativity that has no contradictions. all the
Well, that's
phenomena.
the desirable goal. We want a theory of physics that has no contradictions. The bottom line is that special relativity is contradictory. It has contradictory concepts of time and space. That theory, which is false, okay, special relativity is false. That is the basis of general relativity. So general relativity must be wrong. And they're using general relativity to tell us about how the universe originated in the Big Bang Theory. That's all based on general relativity, which is wrong because special relativity is wrong because it's mathematically bijective, which means the universe is claimed to be not unique by physics because they don't have the uniqueness assumption at the basis of physics in the special relativity theory. I hope I said that correctly. That's why you have all these multiple universe models and all this other hocus pocus stuff, because physics doesn't hold the uniqueness principle in it. It has no uniqueness principle in it. So I can invent any theory I want and claim it's true. The mathematics that I use to test my theory is bogus because we know special relativity is bogus, general relativity is bogus. It's all just a bunch of bogus mathematics. You can't solve the problem until you get the correct theory. Special relativity is not correct. That needs to be fixed. And until we fix that and get agreement that we need to fix that, we're not going to make any progress.
Yeah, hi, thank you. I mean, when I read articles about these multiverses and this idea of Professor Penrose that universe will expand to almost to the infinity, and then again the Big Bang will pop out of nothing. I mean, for me, this is funny. this is really funny, and yeah. I mean, if I see that you are a group of very strong thinkers, if you want, we can work together in next month, because what Harry already now said, this is a very essential point. Interpretation or understanding of special relativity is very weak today, and also of general relativity with this curvature of space. This idea also was somehow accepted in cosmology, and that's why everything is on the wrong track. It's true, Harry.
Well, I mean, I would say that we in the CNPS and in these discussions more specifically, we don't have any orthodoxy. That's contrary to our whole raison d'etre. We form our own view, so it's unlikely that any two of us will have exactly the same view. But I mean, I brought up Harry because he raised this point from a particular viewpoint, which I share a lot of his views, but I wouldn't agree entirely with him. And I would say that your own exposition was actually quite refreshing in that it sort of was an essential critique of existing thinking. But on the other hand, it may be a little less radical in some respects than many of the views held by us here. And I think that there's an opportunity, in fact, to cooperate with each other and maybe share views and share discussions. So if that's all right, Harry, we can maybe leave it at that for the present. And I'll just check because time is running out on us.
Well, my comment would be.
Yeah, go ahead.
My comment would be is focused on what, especially, you have to first agree that special relativity is wrong. Once you've arrived at that conclusion, then you have to conclude relativity is wrong. Okay, and as a result, you can't extrapolate those interpretations into the universe. Now, what happens here in this discussion is people say, well, what's your alternative theory? Okay, well, we haven't decided that special relativity and current physics theories are wrong before, we have to establish that and agree on that point first. Okay. And the physics community doesn't agree on that point. Okay. In my view, that's the first thing that needs to be done. Decide special relativity is wrong. Define why it's wrong. It's not bijective. That's the reason it's wrong. Okay. It's wrong mathematics. You have to make that case and make it strong, get people to realize that, oh, yes, we need to look at alternative theories now.
Mathematics in the special relativity is not exact. We published several articles on this. I can send you this. The idea of Einstein of this relativity, in my view, was a good idea. And actually, what does it mean that time is relative? This actually means that speed of events is relative. But in Einstein's view, this has to do with who is observing and what is observing. What we find out, our research group, that this has nothing to do with who is observing and what is observing. That the relative rate of clocks, of chemical reaction, of biological reaction is only related to the variable energy density of space. So the entire mathematics of special relativity and general relativity is replaced with the variable energy density of space, and everything works well. The problem is, it's not the problem, the fact is that in the scientific community, the general relativity is understood, is thought to be a juveler or a most precious stone of physics, a diamond of physics. And nobody today is ready to discuss that this diamond is really not so beautiful. We published this in physics essays about special general relativity, how we improve it, but we did not have access to any journal of, let's say, big impact factor. I don't know, Nature, scientific reports would never publish something that would say that the general relativity is not such a big thing. So maybe I will die, and then in 50 years they will say, yeah, Šorli was right.
Yeah, that's certainly an interesting point, which we have adverted to on previous occasions. The reluctance of certain journals, to publish certain views, indicating rather disappointingly that science is being pursued in not a totally disinterested and objective way. It's politicized and so on.
Harvey says something very interesting. I would like to answer.
Harvey.
The radius of a black. Yeah, Harvey Shribner.
Where is it said? You're seeing something I haven't seen it yet.
The radius of a black hole.
Chat. I haven't seen it yet. A real radius has to have a real distance.
The Harvey said the radius of a black hole is not a physical radius; it is a mathematical only.
Oh, right.
Look, if you will read our article about stationary model cosmology, you will see that we use several references about these supermassive black holes in the center of galaxies. SMBA, SMBH, SMB, how you spell it? SMBH, like the supermassive black holes.
Right.
This is an established term in today astronomy. So they measure rotation of rotation around the axis of these black holes, angular velocity they measure the distance of the radius, let's say the radius of them. They measure the distance from the Earth. They measure the diameter of the galaxy. So I think that we should be I'm strongly against follow whatsoever, but to say that all this is rubbish and that the black holes has no physical dimension, then somehow we are out of the game.
Yes, sometimes it's the terminology which causes these differences. I mean, for my part, I was quite intrigued by, your exposition of this dragging of space by, an element which is at the center of part of space.
Space dragging effect, yeah.
We needn't call it a black hole, because that's another discussion. But I think we're coming to the end of the discussion, and I think Harvey's essential point was very good. If Harvey will forgive me in not bringing him up to elaborate further on it, because the time really is running out. There are one or two. Nick wants to come back. Anybody wants to come back? No. Okay, Nick wants to come back. If you can do so quickly, Nick, because we're running out of time. Go ahead. No, can't hear you. Wait a minute. I'll have to unmute. Unmute your mic. No. Yes. No.
Brett,
Yeah, got you now.
You said you wanted to have a Zoom meeting, you and I, after this presentation. So I'm just wondering, you still want that, or you want to do that another time?
Did I say that?
No, Amrit.
Oh, sorry.
Offline said, let's have a Zoom meeting after this meeting. You want to do that now or some other day or time?
I can't do now because we have a farm and I have to check animals because my wife is not at home. But we can fix this in the next days. I would be happy. Yeah.
You just send an email
because I have gone out to see the animal.
Yep.
Okay. So if I may, thanks for. I'm glad I got that in, because Denny and I are going to do a Zoom call, but we'll arrange that offline for next week or something. So okay, just bring you down. Well, the time as usual has caught up on us, and it devolves upon me to close the meeting. First of all, I'd like to thank Amrit very sincerely for taking the trouble of giving up his late afternoon and early evening to explain in detail what he's been doing in this whole area of bijective physics, and for having manfully dealt with all the many questions we have and discussions, some of which may not be totally in line with his own thinking, but I mean that's what we're all here for. We're thrashing out these ideas, and if we were all of the same mind, there'd be no point in discussing things. And I'm seeing some of the comments coming in. Thank you very much. Thank you, Amrit. And actually, just to say that some of us have secret chats. We say, oh, if a person is coming on whose first language is not English, we hope he can be understood on these media calls. It's not like face to face. Well, we need have had no concern about that at all, as Nick said, because Amrit was very clear in his exposition, and actually much clearer than many native speakers would have been. So we had no problem there at all. And I'd like to thank Nick actually as well for having introduced us to Amrit in the first place. We do appreciate the handful of regular participants who are helping me. I've been pushed into this job to take it on every second week, and I'm endeavoring to ensure that we don't have gaps. So I'm being helped, and I do thank very much Nick for having sourced Amrit, and indeed such distinguished and eminent person for us, Professor Amrit Srečko Šorli from Ljubljana. So I'll endeavor to close the meeting now. I'd like to thank all of you in the social media for having participated, and all your comments, even though they're frequently just back and forth points you're making among yourselves. I mean, that's part of the meeting. And I'd like to thank all of you in the green room for participating, and especially those who of putting points directly to Amrit. We have the contact now, and if anything further occurs to any of you, or indeed you wish to pursue things further, please feel free. I'm sure Amrit will be happy, or if you want to go through me, that's fine as well. I'm sure Amrit will be happy to take all your comments further. And we hope to see more of you, Amrit, because we're talking about. When I joined this sort of area about 10 years ago, people were saying to me, "Oh, you have a strong presence in Europe in regard to assessing fundamental physics and questioning everything." And I said, "No, you have a stronger system in North America." So even though if you look at the map of sort of people looking at fundamental physics questions, it spans the globe. It seems to be top heavy, I must say, in North America, and I'd be more happy if we got some more Europeans involved. So, Amrit, you're invited whenever you can to come back to us, and we may ask you again. So, thank you very much indeed, everybody, and I'll end the broadcast now. So, good day to everybody. Hope to see you again soon.